Hello, I'm Gordon Henderson, and this is my little Ruby board on the right here and the console to it on the left. I thought I'd do one last thing with the LCD display before I moved on to something else, so I got somewhat sidetracked. Did more than I really wanted to do, or maybe more than I should have done, and I turned it into a little terminal device. Let me just fire up the BCPL system when I get the right disk partition. So I'm now running the BCPL system on the left. It's running on the inside the Ruby terminal, which is a sort of clever terminal. It's connected to the Ruby board via serial link. It's just a 1152 kilobaud serial link, but the terminal itself can interpret various control codes and things to do clear screen, and I've got various editing facilities and so on. I can run commands, HW, your usual Hello World program. If I run a program LCD test, that gives us output on both screens. It looks like at the same time, but it does one after the other. So I can send output to the LCD, I can send output to the screen. This is the actual program. Now BCPL has a Streams I/O system. So what I did was I decided to integrate my little LCD driver into the Streams I/O system right inside BCPL. And you can see sort of down here, this is the start, this is the main. If you're a C programmer, this is equivalent to main. Screen equals output. Output is the current output stream. So this gives us screen as output, which is a bit like std.io if you're a C Unix programmer. LCD says find output, LCD. Now find output is a generic open file for output command. An LCD, if the file's got a colon in it, it's treated as a special device. So LCD is the device there. And LCD gives us the handle. In BCPL terms, it's called a stream control block, which is what SCB stands for here. SCB is like a pointer to a structure that the same as when you do file star FD in C Unix land. And we just call hello screen and hello LCD. So screen select output switches the output to that various stream, and then you've got the same write S, write S, VDU CLS, VDU XY is commands I've written to do the VDU in general. Now the VDU in general, it sends control codes up to your screen the same way you would with any sort of terminal. But I also made the LCD driver interpret the same control codes and do the same terminal operations on here. So clear, CLS clear screen, X550, so 5 along and 0 down. And then write Ruby 3 along and then 2 down, so the third row, 3 along and then second row 2 down. Deplete is the sort of flush command. It just says make sure everything's flushed out. So we switch to screen, which is our screen here. We switch to LCD and run it all. So if I run that command again, LCD test, yeah, there we go. So it does the same thing. I kind of went a step further and I thought, well, this is my little command line interpreter. What if I actually just switched output from the command line interpreter to the LCD? So I wrote a little command inside it, LCD, and we're actually there. I just clear it, we're there. If you're an old Apple II programmer, you might remember the commands PR hash and IN hash. So PR hash would send output, PR printer, to a slot number, so slot number 3 or slot number 2 or whatever. And it's something very similar that's going on here. I just diverted output from my command line program to a different device. I can run our hello world here and various other things. If I run my Pi program, 10 decimal places, there you go. One thing to note is the scroll is all done in software. So whenever the screen scrolls, I've got a software copy of the tiny little frame buffer here, 20 by 4. And to scroll the screen, I scroll it in memory and then I literally redraw the entire thing. It's not very fast. If I demonstrate that, if I run another program, Q0, which is a standard 8 queens problem, on a chessboard. This one actually goes up to, it does 1 through 10. So if you've got a 10 by 10 chessboard, it'll tell you how many solutions, how many queens you can put on. It does take a few seconds. And hopefully at the end of it, it'll print the time it takes. Yeah, so there you go. So that's 18.6 seconds. If I switch back to console, so now we're back to the console here. If I run the same program, it'll be quicker because it's quite, doing that software scroll and redrawing the display is not the fastest thing in the world. Yeah, so it's actually half time, so it's spending half its time scrolling the display, which is not a useful thing to be doing. Anyway, I thought I'd do it just for a little bit of interest, but it also reminded me of a computer that I used in the early 80s, which is an Epson HX20, and it had a keyboard and a little 20 by 4 display and built-in batteries, and it was a built-in tape drive as well. I think it was, people will say it's the first portable computer. It ran BASIC, and I wrote some basic programs on it in that 20 by 4 line display, so they're certainly usable as little displays for something. I believe that display was graphical. This is a pure text display. It doesn't have graphical capabilities other than being able to redefine characters. Anyway, I thought I'd do that to you, and it's probably the last thing I'll do with the LCD for now anyway. And I'll leave you with that. Thanks a lot. Bye.